let's look at the examples. Write each function in terms of its co-function. Okay. Write each function in terms of its co-function. So we have a cos 52 degree. This will be equals to sine 90 minus 52 degree. Okay, 90 minus 52, that will be sine what? Sine 38 degree. Okay, so cos 52 equals to sine 38. That is what we have. And then you're going to take B as your classwork. Then let's take C. So C, sec 24 degree. So in terms of its co-function, so this is let's simplify it a little bit. Sec 24 degree, turn it upside down, this is 1 over cos 24 degree, right? So what can we do here? There's another co-function that we did not discuss, which is very much applicable. So we have sec theta equals to cosec or 90 minus theta. We did not discuss it, but it actually works. Let's check with 30 degree. Sec 30 degree equals to cosec 60 degree. Let's check if it is true. So sec 30, you know that cos 30 is what? So let's prove this. Sec 30 degree equals to 1 over cos 30 degree. Cos 30 degree is what? That's 1 over root 3 over 2, right? If we take the reciprocal, what do we have? So that will be 2 over root 3. 2 over root 3 times root 3 all over root 3, right? So this is 2 root 3 all over 3. Now, let's quickly try to evaluate of cosec 60 to check if they are equal. So cosec 60, I just want to establish an identity, that's why I'm showing it. So cosec 60 degree, you know it is equals to 1 over sine 60 degree, right? And sine 60 degree is what? Root 3, so that is 1 over root 3 over what? 2, which is 2 over root 3, which if we rationalize, we have this, and then the answer is 2 root 3 all over 3. Can you see that they are equal? So this identity is true and this identity is true. So that is co-function. And then we can add it as one of our co-function identity. So let me include that to our co-function identity, that it is true that sec pi over 2 minus theta equals to cosec theta, and that automatically implied that in degree form sec 90 minus theta equals to cosec theta. Okay, so that's what it means. And guys, so you can finish up what we started now, and we don't need the reciprocal again. So what we just need to write is cosec 90 minus 24, okay, which is equals to cosec 90 minus 24 will give us 66 degree. Okay, so we don't need bracket anymore. Cosec 66 degrees. So this is how to use that. So pause the video and take your classwork. Then we'll see in the next note. Example 8. Find one solution for each equation. Assume all angles involved are acute angles. We are still using the co-function identity. So let's take this. Cos x plus 4 equals to sine 3x plus 2. A. Cos x plus 4 degree equals to sine 3x plus 2 degree. Okay. So we are going to change to one of the identities. So let's try to change to sine or cosine. So if we change to cosine, we have that sine 90 degree minus x plus 4 degree, okay, will be equals to sine 3x plus 2 degree, okay, and this implies that sine 90 minus 4, that will be sine 86 degree minus x equals to sine 3x plus 2 degree. Okay, so sine cancel signs now. So when you have the same sign on both sides, you can now cancel the function. And then we have 86 degree minus x equals to 3x plus 2 degree. And then if we subtract 2 from both sides, we have 86 minus 2. Subtract 2 from both sides and add x to both sides. That will be 3x plus x. So 86, this is degree. So 84 degree equal to 4x. So if we divide both sides by 4, we'll have the final answer. So 4 goes in 4, we have 1. 4 here, 4 here, that is 21. So therefore, x equals to 21 degrees. So this is how we apply that. Okay, so you're going to take the second one as your classwork, or easy to add. All right, let's solve it together. So tan 2x minus 18 equals to cot x plus 18. Okay, so b, tan 2x minus 18 degree equals to cot x plus 18 degree. So what do we have there? Yep. So remember that tan and cotangent are co-function of each other. So we can change either side. So let's change the cot. Tan 2x minus 18 degree equals to tan 90, okay, minus, you have to put brackets, 18 degree, okay. So we open the bracket first. So tan 90 minus 18, that will be 72, right? Minus x, and then we have tan on both sides, minus 18 degree. So if we cancel the tan and equate what we have, we then have that 2x minus 18 degree equals to 72 minus x. So add x to both sides and add 18 to both sides. So we have 2x plus x equals to 72 degree plus 18 degree. So 3x equals to, what do we have? This is 0, 8, 90 degree. Dividing both sides by 3, we have 3 and 3, 3 here, we have 30. So x equals to 30 degree. And this is what we have. So this is how to use co-function identity to solve a simple trigonometric problem. So this is all the fundamental identities, guys, and this is how to use them. So in our next lesson, we'll be looking at problems on identity, small problems on identity. Okay, bye.